All right, welcome everybody. Brian McLogan here, and coming to you with another live stream for the second quiz of our chapter on applications of trigonometry. So in the first quiz, we covered the just solving word problems in trigonometry, then using the law of sines as well as using the law of cosines. And then for this quiz, we basically have covered vectors on a plane, the dot product of vectors, parametric equation, as well as polar equations. So that is what is going to be on this quiz, basically looking at applying vectors and parametric and polar equations. So we're going to have, let's see, 4 problems up here that we're going to work on. And then what I'll do is just kind of take a little break, check in with you guys. And before I get onto my multiple choice, but today's been a long day, and I have a lot of grading because I am not started. I'm not through on the grading yet, so I am not going to answer questions here for this this chapter. But I am looking into doing either my students are going to be taking a quiz, or they're going to be taking their test this week. So what I'll be looking into doing, I might possibly be doing a extra bonus live stream this week, but I haven't, either like maybe a Wednesday or Thursday, I haven't confirmed yet, and therefore that one will just be a wide open, if you guys have questions, I'll just answer them, kind of like what we do at the end of these streams, kind of like answering some questions that you guys have, but that one will just be just me going through questions. So, all right, let's go ahead and get started. Now, I am using my TI calculator here because I don't have my regular calculator with me, so that is basically what I'll be going off of from here. All right, hold on one second. Let me check to make sure. You can continue watching if you want. All right. Hey, Bill, what's up? And dark. Oh my God, it's 5 a.m. Wow, 5 a.m. That's early. So right now I am on Eastern Standard Time, so it's 9 o'clock for me. So I'm going to go to this live stream, and then I got some more grading and stuff to go ahead and get on. So, all right, let's get into the first problem. First problem set is a boat is traveling at a bearing of 300 miles per hour at 300 degrees at 45 miles per hour when it encounters a current at a bearing of 15 degrees at 10 miles per hour. What is the resultant vector of the boat? And then I did write this in for my students to round to the nearest thousandth. So I didn't write that in there, but that is one thing I want to do. So, basically we have 2 things going on here. So let's kind of draw this vector here. So we have vector at 300. So we know 300 is going to be 60 away from there. So, basically there's your vector of 300. So we know that angle is basically 60 degrees. And we know that it's going to have a magnitude of 45. Okay, 45 miles per hour. And then it encounters a current at 15 degrees. So let's do that one in purple. So that's going to be at a bearing of 15 degrees, which is going to be right there. So let's say that's 15 degrees. And that one only, though, has a magnitude of 15 miles per hour. So here's what you have. Like, you have this plane that's traveling this way, and you have the wind that's kind of blowing it this way. Or, I'm sorry, the boat. The boat is traveling this way, and you have a current that's pushing this way. So we know the resultant vector is going to be, like, somewhere up here, right? And what we looked at was, we looked at understanding the resultant vector by adding and subtracting vectors by exactly that, by just using what we call the tail-to-head method. So if I had, like, a vector like here, and let's put the purple one actually a little bit smaller, like there. Well, if you just put the tail to head right there, you can see that's roughly going to be where my new resultant vector is going to be, right? So that is going to be basically my boat plus my current. All right, so to understand this red, which is basically the resultant vector that we're looking for, we need to be able to figure out, what would be the vector of the boat and compared to the current. So I'm going to say the vector of the boat. Now, again, we have a magnitude and an angle. So therefore, we're going to use the magnitude angle form. Now, it's very important here for us to understand what is the angle in standard form. So we know the bearing's 300 degrees, and when the bearing's 300 degrees, we know we're 60 degrees away from the y-axis, but that's not the angle that this calculator understands. This calculator understands an angle from right here. So we need to figure out what that angle is from there to there, which in this case is going to be 90 plus 60, which would be 150. So I'll write B is going to be magnitude 45 times the cosine of that's going to be 150 degrees. And then times the sine of 150 degrees. So I'm putting that in green so you can see how where that green kind of comes from. Okay, so that is the boat. And then if I want to identify the current, I'm going to use the same thing. I'm going to use the magnitude here. That's going to be purple. Let's use that as purple. So the current is going to be a magnitude of 15 degrees. And however, the angle is not 15 degrees. 15 degrees is the bearing. We're looking for this angle right here, which is going to be 90 minus 15, which would be 75. So that's going to be the cosine, and I'll put 75 degrees, comma, the sine of 75 degrees. Okay, there we go. So now, again, that's not our question, though. Our question is asking, what is the result of it? What is the red, right? Well, we got to add the blue and the purple. We got to add the boat and the current. So therefore, we're just going to combine them together. And I did ask my students to round to the nearest thousand. So I'm just going to write this all out, how this would be, and then I'm going to figure everything out in the calculator. So basically, what I'm going to be typing in my calculator is going to be adding these two components. So again, remember, you can distribute these, right? So really what I'm doing is 45 times, actually, you know what, I'm going to need a lot of space here because this is going to be a lot. So if I want to find the resultant vector, that's going to be B plus C. Okay, so it's going to be 45 times the cosine of 150 degrees plus 15 times the cosine of 75 degrees. And then the y component is going to be 45 times the sine of 150 degrees plus 15 times the sine of 75 degrees. Okay, now we want to make sure that, again, if we're using a calculator, that we have them in the correct mode. So okay, I'm in degree mode, so that's good. So I'm just going to do 45 times the cosine of 150. Close that parenthesis, plus 15 times the cosine of 75. And rounding to the nearest thousandth, I get 0.9. So again, that gives me a negative 35, which makes sense, right? We know we have to be in the second quadrant. So it's going to be negative 35. Well, we don't know, but it's kind of seems obvious. 0, 8, 9. And then our y component is going to be 45 times the sine of 150 plus 15 times the sine of 75. Okay, and that's going to give me a positive, which again tells me I'm in the second quadrant, which makes sense, right? So that's going to be a positive 36.989. Right. So that is going to be our resultant vector in component form, rounded to the nearest thousandth. So I guess I would have to accept whatever kind of form they gave the resultant vector in, but hopefully they kind of left it in there and rounded it to the nearest thousandth. You can see here it'd be like the exact value of that angle. So a lot of just another different form. But again, the main idea was identifying that resultant vector. And from there, we could go ahead and find the ground speed or the magnitude of that, as well as finding the direction if we needed to. But that's kind of like the basics from there. All right, so the next one is at a golfing range, you hit a ball 180 feet per second at an angle of 15 degrees above the horizontal. Write the parametric equations that represent the height and the distance the ball travels, and what is the distance and height of the ball at 1.5 seconds. So it'd be really nice to kind of have a calculator to do the parametric equations, but I told students that you don't have to have a graphing calculator to do this test, so therefore we're going to do it without graphing or looking at the graph. First thing we want to do is just draw a picture of what's going on. So we have a ball. It's being hit with a degree of 15 degrees above the horizontal, and then eventually it's going to fall back down to the ground, right? So we're looking for obviously the maximum height as well as the distance that the ball travels. So we're looking for this x distance, and we're looking for this y distance, when t is equal to 1.5, and here when t is equal to 1.5. So the first thing we have to do is we have to create our parametric equations. Now, this is something I did give to my students, so therefore they wouldn't have to like figure out where these equations came from. So I did give them the basic equations for parametric equations of particle motion. And if these are something you're not familiar with, the x component would be v sub 0 times the cosine of theta, t, where t represents time, x represents horizontal distance, and y equals negative 16 t squared plus v sub 0 sine of theta, t. So again, this is going to be only for particle motion in terms of feet per second, hence why we're getting the negative 16. And then we have our, and then plus h of 0, where h of 0 is your initial height, which in this case we don't have initial height, so therefore that's going to be 0. So the first step is basically going to write the parametric equations. Well, v sub 0 is our initial velocity, so that was 180 feet per second. And then we have 15 degrees. So literally you just needed to plug in 180 and then times the cosine of 15 degrees. Then times t. And that was it for the parametric equation for the x-coordinate. Then the y-coordinate is going to be, do I get more room? I don't have more room, dang. So it's going to be negative 116 t squared plus 180 times the sine of 15 degrees t and plus h of 0 there. So there is going to be your two parametric equations. Now, let's figure out where they are at t of 0. So in this case, what we're going to do is we actually need to plug in 1.5, and that's really all you need to do. So x of 1.5, just plug in 1.5 in for t. So therefore we have 180 times the cosine of 15 degrees times 1.5. So let's figure out what that is. So I do 180 times the cosine of 15, close the parenthesis, times 1.5. And I'm getting 14.48, and I think I did tell them also to round to the nearest thousandth here. So therefore that's going to be 14.489. Now got to remember, like, what is that? Is that feet? Is that second? It's feet, right? That is your horizontal distance the ball has traveled. So not very far. 10. Or I get 10. Oh, wait. Did I? Oh, that doesn't make sense. Now does it? Right? And I notice I didn't type that incorrectly. I didn't type in 180. So let's go ahead and redo that, because it doesn't make sense. You're hitting a golf ball. It only goes 15 feet, right? Slow down. Check your work. So I typed in a wrong equation, or I typed in something wrong in my calculator, so let's go and try that again. So that looks a little bit better. So the problem answer did not make sense there. And now when I round this to the nearest thousandth, that goes to 0, that goes out, I can round this now. It actually goes to 260.8 feet. And that makes a little bit more sense. All right, let's go ahead and try the y component. So for the y component, hopefully you kind of see what I did. I'm not going to show my work. I'm just going to say y sub 1.5 is equal to. And then now, actually, well, I'll just type it. Yeah, I guess I'll just type it in. I'll just show you again. But I would be okay with you not showing your work here, because you're just showing that you're plugging them in. So just showing y sub 1.5 would be fine. All right, so let's make sure we slow this down to make sure we have this correct. All right, so we have negative 16, and then I'm going to use parentheses 1.5 and parentheses squared plus 180 sine of 15, close the parentheses, times I'll use parentheses times 1.5. And I get 33.8 feet, which doesn't seem very high at all. And negative 16 t squared. But, I mean, I guess you're doing it at a 15-degree angle. That's really, really low. So I guess that makes sense, but I'm not seeing any other issues I might have made, so I'm going to roll with that. Yeah, so round to the nearest foot here, so that's going to be 33.881. No room. Put it down here. 33.881 feet. Okay, so low, right? 15-degree angle, though, is not very high. Definitely possible from that set. All right, let's go and work on these, the next two, and then we'll get into some multiple choice. I'll go and check in with you guys that have joined in on the chat, and I do want to let you guys know that sorry, I'm not going to do any questions tonight. I'm going to try to keep the stream a little bit shorter than usual. However, I am looking into doing a bonus stream that I'll just be able to answer your questions this week. So keep on the lookout. I'll probably make a announcement either on Monday or Tuesday, so therefore you guys can send me over some questions if you have them. All right, let's get into given the following vector PQ, where P is 2, negative 1, and Q is negative 1, 4. Determine A, the component form. B, I forgot to change the answer. C is going to be the angle in standard form. That's going to be in degrees, which I changed for my students. We're going to find the magnitude. We're going to find the unit vector in terms of I and J. That is another thing that I changed on the test. And the vector in terms of the magnitude and the angle. All right. So remember, when we're looking at a vector, we can just kind of refer to them as their components, like P1, P2, and this could be like Q1, Q2. You don't need to understand them that way, but when we're looking into writing the component form of PQ, which again, using correct notation here, is basically going to be the first components. That's going to be Q1 minus P1. So that's going to be a negative 1 minus 2. And then Q2 minus P2. So that's going to be 4 minus a negative 1. So I looked at a lot of students' work. I noticed that a lot of students did not use their parentheses, and they made their mistake right there. So once you make your mistake there, obviously you're going to get everything else wrong, right? So it's very important to be very careful with that. Negative 1 minus 2 is a negative 3. And then 4 minus negative 1 is a 5. And again, you can just think of this as like the distance formula. Instead of P and Q's like x1, x2, y2, or x1, y1, x2, y2, so forth. I also want to make sure that I label my equation, so therefore as I'm grading it, I know where they're finding the component form for answer A. The next one is find the angle B. So to figure out the angle, we need to first understand where this is. And this is in the second quadrant. So we got to be very careful with that because when we go ahead and find this angle, right? So we know that this vector, 1, 2, 3, 1, 2, 3, 4, 5. So there's the vector, right? Well, when I go ahead and use tangent of theta, which is opposite over adjacent, right? That's going to give me this angle. That is not my angle of my vector, right? So let's figure what that out is, but again, that's not my vector. So, I'm sorry, that's not the angle of the vector. So I'm going to do tangent inverse. That's not tangent inverse. Oh. There you go. Tangent inverse of a negative 5 divided by 3. And I get 59.063. I'm going to store that. No. Clear. Okay, sometimes negative 1. Now, again, that gives me a negative 59, right? But again, that's because tangent is restricted. So it's giving me the angle down here, but I can just use the positive version from that, all right? Now, again, that's not the angle of my vector, though. The angle of my vector is in standard form from here. So let's go back. So my angle, first of all, gives me a negative 59.036 when I round to the nearest thousand. But again, guys, that is the angle theta. That's not our angle. So the angle of the vector, which I could give another name, or I can just say the angle of PQ, that's going to be 180 minus theta. But again, not the negative version, but the positive version. So 180 minus, let's see, and that's going to be 120.964 degrees. right? So basically what I did is I took 180 minus the positive version of theta to give that. So the green represents the 121.96. And again, you could give her another one, but don't give it theta if you already used theta to find the area angle in that triangle, okay? The next one is find the magnitude. So the magnitude, again, is, remember, just the first two components, squared, and then take the square root of those, basically the Pythagorean theorem or the distance formula. So using my notation for magnitude, all I'm simply going to do is have the square root of negative 3 squared plus 5 squared. Okay, so negative 3 squared is 9 plus 5 squared is 25, so that's going to be the square root of 34. Don't need to simplify it, that's pretty good. D is going to be the unit vector, so the unit vector, which I'll call U, remember, it's just the vector divided by its magnitude. Well, since I'm writing the vector in terms of I and j, I can just do a negative 3 over square root of 34 I plus 5 over square root of 34 j. And that's basically all I really need to do. I'm just taking 34 and dividing both of my terms of my component vector into there. And then D is basically saying what is the, write the vector in terms of its magnitude and in terms of magnitude and its angle. Well, again, I have the angle of the vector and I have its magnitude. So I know the vector PQ. While component form is very easy, right? We can also write it in terms of its magnitude, square root of 34, and then times the cosine of 121.964 degrees, and then times the sine of 121.964 degrees. Now, I'm rounding these answers, right, because I said to round them. However, what do you think the square root of 34 times the cosine of 121.964 is going to be very, very close to? Negative 3. Let's just have a little fun and let's just do that. Square root of 34 times the cosine of 121.964. And I get negative 3.086. So I'm pretty good. And obviously, again, there are going to be some rounding errors, right? But you can see I'm pretty good. Like, that's pretty close. And then obviously, if I did square root of 34 times that, you'd see that be get to us to 5. All right, the last one here is plot the polar points. So we had the polar points here, and this actually showed up a little bit better. It looks like a little bit better on here than it did for my students on the printing. So we're going to disregard this first line that is that's really at the 15 degree mark. So it's 15, 30, 45, 60, 75, 90. So we're going to disregard the 15. However, if my students went to there, I didn't deny them back out. And then also, we can see there's these darker lines and lighter lines. So this is going to represent the unit of 1, 2, 3, and 4. All right. But again, as long as my students had the general idea, or I could see how these points related, then I'll fine with that. So for A, we can see that, again, remember a polar point, guys, is going to be r and theta. So A represents the second radius, so that's going to be this ring right here. And then it's going to be at the angle 7 pi over 6. Well, 7 pi over 6 is in the third quadrant since we've been doing this for a very long time. That's pi over 6 over, and that's going to be around there. So there is angle A. The next one is B, which is now going to be on the third ring. So that's going to be right around here. And that's going to be an angle of pi over 3. So again, going into this point, there would be our B. And the last one has a negative 1. So what I told students was, don't worry about the negative for a second. Just draw the positive one. So positive 1 is right here. And then 7 pi over 4 is in the fourth quadrant. However, this negative, if you remember, negative is like a scalar. So what it's going to do, just like here, like think of the square root of 34, you're multiplying by cosine and sine, right? So this is like a negative 1. It's like what it's doing is it's going to be reflecting this about the origin. So basically your angle is going to be right there. And I do understand that some of you are probably, still be confused, especially if you're like watching this live stream. This isn't something that you've always been confused on. Obviously, this is just for me to go over the answers for my quiz, so I don't want to get in too depth for it. But it is something definitely that I understand students, will have confusion on and going through there. But at least that's the answer from there. I just want to say a quick little Hi to Sebastian, Liam, Quist, Athol. A lot of you guys are getting into Mariah, love your vids. Thank you. Sarah, very nice to see you. Alyssa and Arson, after the stream, can you put up the quiz and give me an A in your class? Absolutely, Arson, not a problem. I will put up the quiz. I will put up the answers on my website. We'll definitely be on there. But the stream will not be up. You're gonna have to go back to the channel because it takes a little bit for it to decode for there. Mortada says, I'm from Rec. Well, hey, how are you doing, Mortada? It's awesome to hear from you. My favorite YouTube professor. You're very welcome. All right. Axel, a whole bunch of you guys. Good to have you guys in on the stream. And it was Sunday. It looks like, I guess, 9 o'clock. I guess a little different. I know a lot of you guys expected me, go from a Tuesday or Thursday, but I tried to just mix it up. The students are taking tests on, Wednesday and Thursday of this week. Yeah, excuse me, I'm tired. So I wanted to make sure I get a live stream just so I had enough time for us to kind of view things. If not. Oh, Liam, cosine, adjacent over hypotenuse, tangent, opposite over... No, tangent is opposite over adjacent, Liam. Sine is opposite over hypotenuse. Tyler says hi, and hi, Joe. How you guys doing? All right. Oh, you guys helping yours out. It's good. Helping each other out. That's sweet. All right. Let's go and get to the multiple choice, guys. As I mentioned, I'm going to keep this live stream a little bit short, so I do apologize for those of you that maybe had some questions that you want to ask. Tonight is, Sundays are just tough from on there, so I still got a lot of work I got to prepare for tomorrow, so I'm just not going to be able to get into the extra stuff. So, all right, next one is a lot of students ask, hey, is this the dot product or is this multiplication? I said, wink, wink, we didn't cover multiplications of vectors, so this is going to be our dot product. And the basic following of the dot product is going to be multiplying the first two components. So A dot B is you're basically just multiplying the first two components and then adding them to the product of the second two components. So just remember the dot product produces a scalar, does not produce a vector. So that's going to be 16 plus 15, which is 31. Now, the dot product can be helpful because that can help us determine if vectors are going to be parallel, orthogonal, which is another word for perpendicular, or neither. However, we recognize, again, guys, we can graph these like 1, 2, 3, -1. Like we can graph a vector. I and j are in component form, just like we would graph kind of like a line or like a dot, point or a line. So we can think about this. We can also identify the slope using the slope triangle, which is basically like the y component over the horizontal component. So we can compare these. If we want to compare, rather than looking in their orthogonal, which the dot product is helpful because if the dot product is equal to 0, the two vectors are orthogonal. But we can also just look at the change in the y coordinates over the change in the horizontal to see if the slopes are the same or neither. And in this case, you can see that when I take the horizontal over the vertical, you can see that these two slopes are going to be the same, so therefore they are parallel. Question number 7 says, when the parameter is eliminated from the equations, x equals t divided by 2, y equals t cubed minus 4t plus 1, the resulting equation is, well, again, just remember when we looked at completing this, eliminating the parameter, we want to get rid of our t variable. So what we want to do is solve for t in one of the equations. Typically, we wanted to solve for the equation with x. So therefore, I'll multiply by a 2 on both sides. And therefore, I get t is equal to a 2x. Now you're going to plug that back in. So y is equal to a 2x cubed minus 4 times 2x plus 1. Okay, so 2x cubed is going to be 8x cubed, which there's only one of them in there. But again, I'll just finish it up, 8x plus 1. And there's your answer, A. The next one is the 0.10 negative pi over 3 in polar coordinates has our Cartesian coordinates, which is basically the xy components. Now, the nice thing about this one is I think I can figure out this one. No, I can't. Okay, because these are both in the third quadrant. Like, I know right now negative pi over 3 is like right there, right? So I know it has to be in the fourth quadrant. Well, so that means the x component is going to be positive, the y component is going to be negative. So it's not going to be A, it's going to be one of these two. Well, now I just got to figure out, well, what is this coordinate point at negative pi over 3? Basically meaning, it's kind of like actually down here. which is going to be, have a reference angle of pi over 3. So as long as you remember the unit circle, this one isn't that bad. This coordinate point here has the reference angle, that's going to be 1/2. So it's going to be a positive 1/2, comma, negative square root of 3 over 2. So that's the point on the unit circle. And then all we're really doing is multiplying that by 10, right? So it's really like, 10 times 1/2 negative square root of 3 over 2, right? Or x equals r cosine of theta, y equals r sine of theta. But hopefully you can see from this that it's just going to be the last equation, C. And last but not least, guys, here to finish off my stream, it says the equation r times sine of theta plus cosine of theta equals 4. What is that going to be? Well, again, we can distribute here. There's r, so therefore we get r sine of theta plus r cosine of theta equals 4. Well, remember, guys, r sine of theta, just kind of like what we did up there, is represented by the y coordinate. R cosine, why am I putting equals? That's going to be plus an x equals 4. And you guys can see that y plus x equals 4, that's going to be the equation of a line. So there you go, ladies and gentlemen. That is our vectors, parametric, and polar quiz. Again, make sure you guys stay tuned. I'll look into probably making an announcement on Monday or Tuesday for a live stream, and therefore I will I'll post some things for you guys if you have questions or if you guys have tests coming up in your own classes. I'll be more than happy just to do them and not cover anything else I'm covering in my class, because my students will be taking a test, so they're not gonna have any work to be able to cover. But otherwise, guys, I am going to keep this short, so I do apologize for those of you that had questions. I do see Emilio and Chris. I see your comments, and very happy to be able to help you out, Chris, as well, Emilio. So just keep working hard, guys, and then I look forward to checking out with you guys this week. Otherwise, hope you guys have a great week,